Betelgeuse is a red giant star. Assuming you put it where the Sun is, it would stretch out to the orbit of Jupiter. This tremendous, entirely temperamental star is going to detonate. These blasts are among the greatest eruptions of radio energy in the whole universe, producing more energy than 1 billion suns. Betelgeuse, a monstrous red star, one of the nearest stars to Earth, has recently undergone a striking dimming that has captured attention and stirred emotions worldwide. This dimming has led to speculation among astronomers and the public about its expected ramifications. Some researchers believe the strange behavior could be a forerunner to a cosmic explosion, a destructive event that happens when a star depletes its atomic fuel and implodes under its own weight, prompting an enormous blast. Such an event raises concerns not just among scientists but also among the general public, as it raises questions about the potential effects on our own planet. Betelgeuse is a prominent part of the constellation Orion, easily recognizable in the night sky due to its unmistakable shape and brilliant stars. Also referred to as Alpha Orionis, it holds the title of the brightest and largest star in this constellation. Ongoing data gathered by NASA's Hubble Space Telescope alongside observations from various observatories has shown that Betelgeuse experienced a huge mass ejection in 2019. This behavior is extraordinary for a star of its kind and has provoked the interest of astronomers worldwide. While coronal mass ejections are common events for our own Sun, the unique outburst seen in Betelgeuse adds an interesting layer to our understanding of celestial life cycles and the dynamics of massive stars. The distance to Betelgeuse remains a subject of discussion among astronomers. Some estimates suggest it is farther away, while others indicate it could be as close as 724 light-years from Earth. Accurately determining the distances of red giant stars like Betelgeuse is a complex challenge due to their vast sizes and unique characteristics. Betelgeuse stands out as one of the most brilliant stars visible in our night sky, boasting a luminosity roughly 100,000 times greater than that of the Sun. However, this unimaginable brilliance comes at a tremendous cost. Betelgeuse consumes its atomic fuel at an accelerated rate, hastening the inevitable end of its stellar life. Eventually, the star will deplete its fuel supply, leading to a dramatic collapse under its own gravitational pull, potentially resulting in a cosmic explosion that could give birth to a neutron star or even a black hole. If a supernova were to occur only a few light-years from our planet, the consequences could be devastating. The explosion of a supernova can release an extraordinary amount of light, possibly matching that of an entire galaxy. So, even if Betelgeuse is relatively far away, like Alpha Centauri, the effects of its supernova could still be significant and widespread. Remarkably, since the last known supernova seen in our galaxy in 1604, humanity has not witnessed such an event locally. However, a notable supernova occurred in 1987 in the Large Magellanic Cloud, about 169,000 light-years away. While that event had massive implications for astronomy, it posed no direct threat to Earth, serving instead as a reminder of the scale and potential impact of such cosmic phenomena. The concept of a risk zone surrounding a typical supernova is fascinating and could have serious implications for life on Earth if such an event were to occur nearby. Still, it's important to understand that in the grand cosmic scheme, supernovae are relatively small events compared to gamma-ray bursts, which are vastly more powerful and pose a different kind of danger. Supernovae can have devastating effects capable of destroying biospheres and flooding worlds with lethal radiation. For instance, certain types of supernovae can lead to the destruction of a planet's ozone layer, leaving it vulnerable to harsh ultraviolet radiation long after the initial blast. This possibility was highlighted in a recent study that outlined new potential risks posed by massive stars ending their lives in spectacular explosions. When giant stars detonate as supernovae, they can reach some of the highest luminosities known in the universe. In fact, the brightness of a single supernova can outshine the combined brilliance of billions of stars. This raises the question, what would happen if Betelgeuse were to explode? If a supernova occurred, Betelgeuse would become the second brightest object in our sky after the Sun. Surprisingly, despite its distance, Betelgeuse, which already shines brighter than a full moon, would become visible during the day. The sheer force of the explosion would result in a display so dazzling that shadows would be cast even at night. Such a sight would be both awe-inspiring and terrifying, demonstrating the raw power of cosmic events. While the visible light emitted by a supernova is indeed intense, it represents only a fraction of the total energy released. Although bright light can pose dangers such as temporary blindness, the greater threat comes from the high-energy radiation produced alongside it. This radiation often includes X-rays and gamma rays, which can have wide-ranging consequences. One of the most significant risks is the radiation's ability to strip oxygen from Earth's ozone layer, which protects the planet from harmful solar radiation. Without this protective layer, life on Earth would be exposed to dangerous ultraviolet rays from the sun, potentially leading to mass extinction events. In the aftermath of a supernova, various threats continue to emerge. Initially, intense radiation poses an immediate hazard. Over time, however, vast streams of subatomic particles traveling near the speed of light begin to enter the solar system. These cosmic rays can erode ozone layers and expose Earth's surface to damaging radiation, amplifying the danger of the original explosion. Moreover, these particles carry a large portion of the supernova's energy, and their effects can persist for centuries. There is evidence suggesting that such events may have impacted Earth in the past. Elevated levels of iron-60, a radioactive isotope produced in supernovae, have been found in ocean sediment and lunar soil. This implies that Earth may have been struck by supernova debris in relatively recent geological history, perhaps within the last few million years. Astronomers currently believe there are no nearby supernova candidates posing an immediate threat to life on Earth. However, ongoing research has uncovered additional risks linked to certain types of supernovae that emit long-range, lethal radiation. The mechanism behind this involves a dying star surrounded by a dense disk of material. When the supernova occurs, the shock wave strikes the disk, heating it and producing a burst of high-energy X-rays capable of traveling immense distances. The most powerful of these X-ray supernovae could destroy up to half of a planet's ozone layer, creating conditions that could lead to extinction within a 150 light-year radius. Fortunately, no such candidate stars have been identified near Earth. However, this research has led to new insights about the cosmic habitable zone, the region within a galaxy where conditions are favorable for life. These findings suggest that this zone may be more restricted than previously believed. Specifically, the outer regions of a galaxy may lack sufficient star formation to create the elements needed for rocky planets, while the inner regions may be too violent due to frequent star deaths. While Earth's biosphere will likely remain unaffected, the spectacle itself will be unforgettable. Scientists predict that Betelgeuse will continue to shine brightly for more than 90 days after the explosion, reaching a glow about half as bright as the full moon, many times dimmer, but still visible in daylight. It will appear as a bright point in the sky, casting shadows at night and captivating all who see it. This event will undoubtedly spark global fascination. As the supernova remains visible to the naked eye for months, its remnants will gradually fade. Researchers will continue to study Betelgeuse, gaining insights into the life cycles of massive stars and the processes that lead to their explosive ends. Understanding these events is essential for grasping how the universe evolves and how the elements are forged during stellar explosions. The light produced during a supernova creates a wide range of heavy elements like gold, silver, and uranium formed in the intense heat and pressure of the blast. This process, known as nucleosynthesis, plays a crucial role in enriching the interstellar medium with the building blocks of life, which can later be incorporated into new planetary systems. This cosmic cycle of creation and destruction enhances our appreciation of the universe and reminds us of the interconnectedness of all things. While Betelgeuse's supernova may still be many light-years away, it serves as a reminder of the powerful forces shaping the cosmos. As Betelgeuse nears the end of its life, it teaches us about the universe's impermanence and the constant cycle of cosmic renewal. The star's eventual death, as dramatic as it may be, will contribute to the birth of new stars, planets, and possibly even life elsewhere in the galaxy. When Betelgeuse explodes, it will release vast amounts of energy and elements into the surrounding interstellar space. This includes carbon, oxygen, and nitrogen, key ingredients for life. The remnants of Betelgeuse's explosion will form a supernova remnant, a glowing nebula of gas and dust. Over time, this material will spread out, enriching the surrounding space and helping to trigger the formation of new stars. The shockwave will compress nearby gas clouds, encouraging the birth of future generations of stars.